Hi dear students and viewers, welcome back to our channel Anvinay Kumar Basics of Physics. Dear students, in this video we are going to discuss about the one of the most important topic for IPE, Intermediate Public Examination. Not only for IPE, it is very important for competitive exams also. What it is, the topic is what is vector product and explain the properties of vector product with examples. So very important children, so don't skip the video, watch the video up to last. Clear? What is a vector product? Dear students, the vector product of two vectors gives another vector. If you can multiply the two vectors, we will get the one more vector. Clear? That's why it is known as the vector product. The perfect definition is the vector product of two vectors is equals to the product of magnitude of their vectors and sine of angle between them. That should be called vector product. If A is one vector and B is another vector, then A cross B is written as mod of A mod of B sine theta into n. Here n is the unit vector. Clear? A cross B. Look here, equation is there. The vector product of two vectors is equals to the product of their magnitudes and sine of angle between them. A cross B is equals to mod A mod B sine theta n. Here n cap it is there. It means that n is the unit vector. Its magnitude equals to 1. So here in this case the vector product should be like this. Here the n is the unit vector and we are showing like this. A cross B is in this direction and n is also in the same direction. Clear? N is a unit vector that should be perpendicular to the A and B. It is perpendicular to the both A and B vectors and that should be perpendicular to the plane of AB. Clear children? So ఏవైతే ఒక వెక్టర్ ఉంటుందో ఆ వెక్టర్ అనే మనకి A క్రాస్ B అని తీసుకుంటున్నాం. ఆ A క్రాస్ B డైరెక్షన్ లోనే n ఉంటుంది. ఆ n అనేది that should be perpendicular to the A and B. Look here, where n is the unit vector perpendicular to the both A and B. So are perpendicular to the A and B. So this is simply about the definition of vector product. So children, vector product also called as cross product. Remember that one. Dear students, if A is vector and B is another vector, then how we can write the A cross B? It is quite similar to the finding the data of the matrix, like that. Got it children? So A is one vector. Here we are taking now A is equals to, we are writing vector A is equals to AXI AYZ and AZK, and similarly vector B is the BXI BYZ BZK. Then how we can write the A cross B? Cross product of two vectors, how we will get? Like this children. So first we have to write the S, coefficients of I, J, K, coefficients of I, J, K. So this is the I, J and is K. In the vector vector A, I coefficient is what? AX. That's why I am writing here this is AX. And J coefficient is what? AY. K coefficient is what? AZ. Clear? In the same manner, for the vector B, what do I similarly here? I coefficient is BX, J coefficient is BY and is now BZ children. So after that simply we can write like this, A cross B is equals to I of. So we have to take the omit this column and this row. Simply what we have? AY BZ. So AY BZ minus BY AZ. BY AZ minus of J of. So now we can go for, we have to omit this column and this row. Then what we have? AX into BZ. This one we have to omit this column and this row. What we have? AX and BZ minus BX into AZ. So children, bx into az plus k of, now we have to omit this column and this row, then what you have simply here, ax by minus bx ay, ax by minus bx ay. So in this way children, we can find out the a cross b, a cross b. Very simple. Dear students, this model is very important for 2 marks in your IB examinations. The same question will be asked. They will give force value and position vector value. We have to find out the torque. So based on that we have to do this one. Now let's go for properties of vector product. The first thing is vector product never obeys the commutative law. For example, if A and B are two vectors, then A cross B is not equals to B cross A. This is nothing but does not obeying of commutative law. Look here, it does not obeys the commutative law, that is A cross B is not equals to B cross A, but A cross B is equals to mod of B cross A. This is the first important one. Vector product not obeys the commutative law. Clear children? The second one is the vector product can obey the distributive law or associative law. It means that if A, B, C are three vectors, then A cross of B plus C is equals to A cross B plus A cross C, like that. Vector product can obey the associative law. It is also called as distributive law. So what it is, A cross of B plus C is equals to A cross B plus A cross C children. This is another important property. See the next property children. If you can take two vectors which are in perpendicular, then the product of their vector product is maximum and that should be equals to the product of their magnitudes. Look here children, the vector product of two perpendicular vectors is equals to the magnitude of their vectors. So here mod of A is equals to mod of B, A cross B is equals to mod of A, mod of B, and sin theta. This is the formula. When we consider perpendicular vectors, theta is equals to what? 90 degrees. Theta is equals to what? 90 degrees. Then what do you write? Simply as A cross B is equals to mod A, mod B, sin 90. So sin 90 is 1. That's why here what write? A cross B is equals to mod A, mod B children. So the vector product of two vectors must be equals to the product of their magnitudes when they have angle is 90 degrees children. So in the same manner, if you can write like I cross J, it is all same thing. What it is, this is the x axis that is represented by the J, this is the y axis that is represented by Z axis. So I cross J, I cross J also what write? Mod of A into mod of J into and sin 90 degrees. Then what you get? I cross J is equals to mod I mod J, like that. The vector products of any two vectors gives a null vector. This is possible only when the theta is equals to 0 degrees and theta is equals to 180 degrees. If the vector product of two non-zero vectors gives a null vector, then those two vectors are called collinear. So children, look here. The vector product of two non-zero vectors will be vanishes or gives the null vector when theta is equals to 0 or 180. Look here children, we are writing A cross B mod of, or A cross B is equals to mod of A, mod of B and sin theta. Here theta is equals to 0 means what? These vectors are parallel or anti-parallel. 180 means what? Anti-parallel. So if you can take a two parallel vectors, then obviously theta is equals to 0 degrees. Then what to write? Mod of A, mod of B, sin 0 degrees. Sin 0 will value it is 0. Then what you have to write? As A cross B is equals to 0. 0 nothing but what it is? Null vector. Already we know that what it is. We know the vector product of two vectors. The vector product of two vectors gives another vector. That's why here 0 is nothing but what it is? Null vector, children. So in the same manner we will write I cross I is equals to j cross j is equals to k cross k is equals to 0. Vector product of cell vector, vector product of self vector gives a null vector. Right, children? So like same thing here, a cross b is equals to mod of a mod of b sin theta we are writing. When we consider I cross a, again mod of a I mod of I and sin theta. Here I represents the x axis, I represents the x axis. That's why both are parallel. The value is 0, children. So these are the properties of a vector product, children. So children, examples for vector product. The first thing is tau is equals to r cross f. What is tau? Torque. Tau is equals to r cross f. Here torque is the vector, force is the vector, and position vector also vector. Tau is equals to r cross f. This is the one example. And next thing is relation between linear momentum and angular momentum. That is what L is equals to r cross p. And similarly here the relation between linear velocity and angular velocity. V is equals to r cross omega. In the same manner, the force acting on a charge in a magnetic field, that should be given by the formula F is equals to Q of V cross B, and the torque acting on a dipole, tau E is equals to P cross E. So children, you may get these two formulas in your intermediate second year. I think this already came in the 10th class, and it will be come in the intermediate second year, children. So children, this is about the vector product and properties and examples. If you can understand this one, like, share, comment the video and subscribe our channel to get all the notifications. Thank you for watching.